and just did some of those Algebra 1 concepts that you haven't seen for a while. So, our goal for lesson 1 is to identify domain and range. In order to do that, we need some important vocabulary. Now, you don't have to copy it word for word. You can take what is important to you from this. So, domain is the set of all first coordinates, aka the x coordinates from the ordered pair. Range is the set of all second coordinates from the ordered pair. So domain is typically the x values, range is the y values. Good. I tried to figure it didn't help. Okay. A coordinate plane is the intersection of the horizontal and vertical axes. So it's the x-axis and the y-axis. They meet at what we refer to as the origin. So the x and y axes meet at the origin. The origin is the coordinate points 0, 0. A coordinate plane is broken up into 4 quadrants. So you have quadrant 1, which is over here in the first quadrant to the right. And then we go counterclockwise for our second quadrant. So quadrant 2 is up here to the left. Quadrant 3 is down below. And quadrant 4 is to the right of that. So you have quadrant 1, 2, 3, and 4. Okay, a relation is a set of ordered pairs. A relation is a set of ordered pairs. We may map relations by matching each element of the domain with an element of the range. We map relations by matching an element of the domain with an element of the range. A function is a particular type of relation in which exactly one element of the domain is paired to one element of the range. All right, so let's look at a couple examples. State the domain and range of the relation. When you are stating a domain and range, you have to remember a couple of things. When we are stating the domain, you need to make sure that you put brackets at the beginning to determine that this is a set. The brackets determine set notation. The domain is the x values. If you're taking a standardized test, they are always going to list them from least to greatest. So the smallest x value is -7, then 2, 4, and 5. The range is the set of y values. So -3, -2, 6, and 7. The y values are the second coordinate in the relation. All right, let's look at example 2. Name the quadrant in which the point 3, -9 is located. So you have a positive x value and a negative y value. So what quadrant would you have positive x's, thanks, Stephen? Good. So we're going to have positive x's and negative y's in quadrant 4. So this is an extension of example 1. We're going to list the domain. We're going to list the range. But now we're also going to determine if it is a function. Everyone give me my domain. Okay, so your domain is -2, 0, 1, 2. Your range, now this one you have to be particular about. Do not write -3 twice. We do not duplicate numbers that repeat in our sets. So even though there's a -3 twice, we do not repeat it. So the range is -3, -2, and 8. And then, is this a function? Well, the definition of a function is for every x, there is only one y. So what you need to do is look at your original function and say, do any x values repeat? Do any of the x's repeat in this problem? No. What does repeat? Y. A y value repeating means that it is not onto, but it does not mean it's not a function. So is this a function? Yes. State the domain and range of each. A table doesn't change that the x values are the domain and the y values are the range. So my domain is still the set of 1, 2, 3. My range, and again, guys, I'm not sure how pretty your brackets are. You can tell, like, mine are just kind of messy. As long as I can tell you tried to draw a bracket, that's fine. Some people take a lot of time to try to make them perfect. The range is 3, 4, 7. Looking at the x's, none of those repeat. So since none of my x values repeat, it is a function. Okay, This is called a mapping. A mapping takes it from one box to the other. The domain is the x's, so it's -2, 0, 4, 6. The range are the y's. What's nice about a mapping is you don't have to worry about anything repeating. The arrows tell us that it goes from the left number to the right. So this -2 going to -2 is kind of like the ordered pair, -2, -2. On a mapping, we know that something is a duplicate or a repeat if there are two arrows going off the same number. So because 6 goes to 5 and -2, this is not a function because that 6 repeats in our domain. All right. Here we have a set of ordered pairs on a graph. So to determine the domain, you're going to want to look at the x values. So your first x value occurs here on this line. So that's an x being a -1. Then we have a point here, that's at 0. This point here is at 1. And then this point over here is over 1, 2, 3, 4. The range comes from the y values. So they're going to come from these points here. So what I do to find the y's is start at the bottom. So I'd start with this point here. So y is at 1, 2, 3. Then it goes to this point, so -1, 0, again, it's okay to circle them, mark them, kind of like I did. We know that it's a function if it passes the vertical line test. You'll probably remember hearing that from before. That means, can you draw a line straight up and down and it only hits once? In this case, the answer is yes. So it's a function. So your homework, you're going to have a double part homework. You're going to do page P5, and we're going to do the second part of the lesson. We're going to do lesson 02 today, I think, as well, right? Because I want you to be at 03 on Wednesday. Yeah, so we're doing 01 and 02 today. And I believe, so if you want to write down, this is the first part, T5, number 1 to 12, and it's posted in Moodle. And then that's in the textbook that's also on Moodle. So if you guys played around with Moodle, you see it says Chapter 0 textbook. Thanks for answering. Oh, Steven, are you checking it now? Yeah. It's page P5, 1 through 12. And again, on Moodle is your textbook. If you want a real textbook, we can sign this out either at the end of class today or tomorrow. But the PDF is on Moodle, and I know you guys don't really want to carry around a math book all the time because they're heavy. But if you want a math book, I will gladly give you one. All right, this should be really easy and somewhat of a simplified review. I actually think lesson 02 is easier than 01. What is 3x times 2x? 5. Alexis? Squared. Perfect. 6x squared. All right, what method do I have to use in problem number 2? What do we call when we take that 4 and multiply it to both of those? What do you think? Yeah, we're going to distribute. Awesome. Look, you guys are using all your math terms. We're going to distribute the 4 to both. 4 times 2x is 8x. And 4 times 9 is 36. Just be careful, there's a minus in there. Okay, same thing down with number 3. We're going to distribute that x. When you multiply 2 x's together, you have 2 of them, or x squared plus 6x. How many of us like this better than definitions and like all the vocab we just did? Yeah, this is like true algebra. We're going to be doing this all year. Okay, multiply or distribute. It doesn't matter that this is a y now. The rules stay the same. Y times 2y is 2y squared. Apparently I put my hand on the iPad. Y times negative 6 is negative 6y. Is 5 still distributing? Yeah, is multiplication. Multiplication is what property? It is, starts with a C. Good? Yes, commutative. So that problem can actually be rewritten to look like this because multiplication is commutative. The order doesn't matter. So we get x squared minus 1x. We have a tendency to rate the highest power first. So again, that's called, when you rate it from the highest power to the lowest power, anybody know what that's called? You will by the end of this year if you don't know. All right, so lesson 2 is FOIL. Anybody remember what FOIL stands for? Oh, somebody I haven't heard from. I've heard from these 3 all day. How about the right side of my room? You don't know? You don't remember? Go ahead, Tessa. Perfect. First, outer, inner, last. So what that means is first, we're going to do the x to the x. For x. And you get x squared. Outer. Negative 6x. Inner. 2x. Last. Negative 12. What's the last thing I need to do before this problem is done? What are these 2 terms right here called? Yeah, like terms. So we got to combine them. Oh, that German's going to give me a headache. Next. 2 times 3 is 6. Y times y squared. 5 times 3, 15y. 2 times 2, 4y. And 5 times 2, 10. How many of you had your 4y and 15y flipped? Yeah, because you did the true, right, you did the true outer versus inner. Addition is also commutative, right? So it doesn't matter if I flip them. Ultimately, we're going to get 6y squared plus 19y plus 10. Yes, Stephen.
Where is it?
The stadium, I believe they have to be outside when they can be. So they're in the stadium. And what is this? It is a word problem. You shall get used to word problems in this class. Many of you are what? You're all sophomores? So all of you next year are going to be taking that SAT and the ACT. A large majority of those questions are word problems. They know you know how to do math. What they want to know is, can you interpret the math? So we will have at least one word problem on every homework and on every test. So again, I'm just trying to prepare you for what is to come on future assessments. So this problem says the glass portion of the window has a height to width ratio of 3 to 2. So that means that the height is like the 3 and the width is like the 2. The height of the glass portion can be represented as 3x. So where I wrote that 3, we're just going to add a little x. And the width as 2x, so we're just going to add an x. And then it says the wood trim adds 7 inches to the width. So remember, the width is the 2x. So the wood trim adds 7 inches to that. And 8 inches to the height. So that 3x has to add 8 inches to the height. So what that means is, like, the inner part of the window is just the 3x, and the inner part of the window is the 2x, and then the outside adds that 7 and the 8. Write a polynomial expression that represents the area of the window, including the wood. So what's the formula for area just in general? Area is equal to what? What? Length times width. But in this case, instead of length, we might call it height, because the problem's talking about height. So area is height times width. So what is my height, including the wood trim? Well, the height is that 3x plus 8. And the width is that 2x plus 7. So to simplify that and get the area, we have to use what method? Thank you, FOIL. You know the title of the lesson? So you get 6x squared plus 16x plus 21x plus, 8 times 7 is 56. I'm just making you guys do some mental math. So you get 6x squared plus 37x plus 56. What would the units be for this problem? What would the units of the area be? Go ahead. Area. Doesn't this mosquito, you guys got it? Yeah. So area is inches squared. On page P, oh, it's not on there. It is on page P. Oh, I have to look on there. I believe it is P6, maybe P7. And I don't know either.